Good evening, everyone, and once again, welcome to this session. It's session number 7 of the training program that the South African Mathematics Foundation is running in order to help learners in high school. And in this particular session, the junior session, it means we are helping people in grades 8 and 9. Welcome. I recognize many names, and I am very happy to see that many of you are still continuing to attend these classes. I hope you go on till the end. We have, apart from this, we have 3 more. And even if there are examinations, please try to set aside these 1.5 hours to these lessons, because this will help you in a very, very major way to be good in mathematics. It's much more than what is done at school, and you will learn how to solve problems and especially think out of the box. All right, the questions have been already sent to you, and I trust that you have had a look at them before coming here today, so that when you see the results, the solutions, you'll appreciate them. Mathematics is a very beautiful subject, especially when you see the creativity and the beauty of solutions which you think are impossible to attain. So with those few words, we'll go straight into today's lesson. Okay, Kotso, can we see the screen?
Yes, Prof, I can see the screen.
Okay, thank you so much. All right, so we go straight to the first question for today, which is, okay, the following. Kevin received a 100 gift voucher to be spent at a store. He aims to purchase 20 items using all the money. The items he is interested in are pens at 5 rands each, notebooks at 7 rands each, and rubbers at 2 rands each. All right, let me first, we don't know how many he is going to buy of each, and that is the question here. So let us say he buys for pens, we'll put P. This is P equals the number of pens he buys. And likewise, N for notebooks, and R for rubbers or erasers. Okay. So, you know, he buys 20 items altogether. So therefore, we have the items that he buys altogether are actually the sum of these 3 numbers that we have. So we will write that down as P plus N plus R equals 20. All right, so that's the total number of items he buys. Then it says that the pens are 5 rands each. So each pen is 5 rands. So you will spend 5 times P rands on pens. All right. Likewise, each notebook is 7 rands. So on N notebooks, you will spend 7 N rands. And on rubbers, you will spend 2 rands each. So that's 2R. So this is the total amount of money you will spend, well, I mean, for each one of them. And when you add them, that will give you the total amount of money that he spends, and he's got 100 rands, I think it says that he spends all his money, right? So it's not less than or equal to 100, which is, if you said he spends at most 100 rands, but he spends exactly 100 rands. Okay, and he buys at least one of each of these three items, which means that P is, each of these numbers is greater or equal to 1. So just hold on with that. P is greater or equal to 1, N is greater or equal to 1, because he buys at least one of each item. So we've taken all the information and we put it down into the form of symbols and equations. But now we've got two equations and three unknowns. And normally you'll need three equations and three unknowns to solve. All right, the important thing here is that these numbers P, N, and R are whole numbers. They are numbers from the natural numbers. Right? So that helps a great deal. Okay, let me just say something about this. Whenever you got natural numbers and you got equations, one of the most important things about that is with the natural numbers, you can perform certain things. Okay, like any other numbers, you can add, you can multiply, and so on. But one of the interesting things for natural numbers is factorization. See, if you got, for instance, if you got the product, say M and N, are natural numbers, that means M equals 1, 2, 3, even if they are integers, plus or minus 1, plus or minus 2, these are integers. The product of two integers equals 20. You can say what M is, because then M is then will be a factor of this. See, M times something is 20, so M is a factor. And you can work out, you know what all the factors are. So this gives you an idea of what M is. You can write it down, because there are only a certain number of factors for 20. So you can say M is one of these numbers. So when you have an equation involving two unknowns with integers, or if they say natural numbers, it's even better, because natural numbers are positive integers. They can't start from 1. Then it's not like saying xy equals 20. I usually use these for real numbers, where x could be anything. If x could be uh, 5 over 47, for instance. And in that case, you can calculate y to be equal to 20 divided by 5 over 47. All right. But yeah, you can't say what x and y are. There could be infinitely many of them if you did not know that x and y are natural numbers. So this is very important, that you could product of two natural numbers. It means one of them is a factor. All right. So that makes us feel a little bit happy, because we know we can still possibly solve this. Okay, now how do you go around solving? You've got three unknowns. The usual method of solving equations is multiply each of them by something and then add or subtract in order to eliminate an unknown. Okay, you've got two equations. You can always eliminate an unknown by getting the same coefficient in, in one of the equations and then adding or subtracting the two, and that thing will just disappear. Like in this case here, you can multiply this by 7 if you like, and then you'll have 7n. If you multiply this by 7 right throughout, then you can subtract and the 7n's will cancel. Or you can multiply by 2 and then subtract and the r's will cancel. But yeah, in this particular case, I noticed that 20 is 5 times 100. So it will be useful to multiply the top one by 5, because then when you're subtracting, the 100 minus 100 becomes 0, which is very nice. So you don't have any numbers there. So let's multiply the first equation by 5. You've got three choices, But I've chosen 5 because 5 times 20 is 100. So I'm taking this equation and I'm multiplying it by 5. Okay. Now when I subtract 5p minus 5p, let's subtract downwards because then I have positive numbers. 5p minus 5p is 0. 7n minus 5n is 2n. And 2r minus 5r, oh, that's negative. That's negative 3r. It's 2r minus 5r, negative 3r. And that is equal to 100 minus 100, which is 0, which is very nice because now you've got 2n equals 3r. So in other words, I can solve for n. N is now, in terms of r, you can make n equal to 3r over 2. I'm not going to do that. I'll tell you why just now. Because this is a fraction and I don't like working with fractions. So, but this equation is useful because it says that wherever I have n, I can put r. So n now disappears. You don't have an unknown in n because that can be replaced. Wherever you see n, you can replace it with this. And so there are no n's anymore. And one of the unknowns is gone. So let's try to do that. I've got 2n equals 3r. Let's create, instead of putting n here, because then you say, I work with fractions, let's multiply this by 2 to get the 2n. So you get 2p plus 2n plus 2r, I'm sorry, 2n plus 2r equals 40. So you multiply right throughout by 2. And the reason for doing that is that I'm going to replace this 2n by 3r. So you got 2p plus 3r plus 2r equals 40. Right, now you see n is gone. 2p, let's get the r's together. And there are no fractions. 2p plus 5r equals 40. See, by multiplying it by 2, I don't use that one there. Get involved with fractions. Now this is very nice. 2p plus 5r equals 40. And I see 5 goes into both of these. So let me put this as 2p equals 40. Bring the r's to the other side. 40 minus 5r. So you have now, I'm going to create space here. I have 2p. Let's take the 5 out. 5 into 8 minus r. Right, now remember, all these are integers. P is greater or equal to 1. So it means that these are positive numbers. These are positive integers. This is an even number on the left-hand side, right? Because it's 2 times an integer, a natural number, a counting number, greater or equal to 1. So it's an even number. And here you got a multiple of 5 because it's 5 times something. All right, so you got, in other words, this whole thing is a multiple of 5. I want to just focus on that. It means that 2p is a multiple of 5. Right? So 2p can't be 5 because then p is not an integer. But 2p can be 10. You see? So the point about this is that 2p is a multiple of 5. 2 and 5 have got no common factors. So this means that p is a multiple of 5. P has to be a multiple of 5. Because you try putting uh, for 2p to be a multiple of 5, 2p can't be 5, but it has to be 10. And then p is 5, you see. 2p can't be 15 because 2p is even, but it can be 20, in which case 2p equals 20 and p equals 10. In other words, p is a multiple of 5, if you think about it. Okay, so how do you... So let's write that down as an equation. Therefore, p is equal to, say, 5 times something, say 5 times m, where m is a positive integer. M is equal to 1 or 2 or 3 or something. Now, let's just watch out here. So what is happening here is that I'm going to create more space on the side. At the moment now, I have that p is a multiple of 5. But just remember that the sum of p, n, and r is 20. Let's just focus on that. Okay, he needs to buy 20 items altogether. Now, all these are positive numbers. So you have that. Let's do it like this. Instead of making this rather complicated thing, you can say p is equal to 5 or 10 or 15. Right? It's a multiple of 5. It could be 0, but it says that you're not allowed to have 0. You need to have at least, p is at least 1. But now you can't go with dot, dot, dot here because this p is less than 20, you see. So these are the only values for p. Because p is less than 20. The sum of 3 numbers is 20, so each one of them is less than 20. So we have to stop right there. P equals 5, 10, or 15. So there are only 3 possible values for p. You see how we are zooming in on this thing? Right? Just by using multiples and these are whole numbers, you can say what p is. So let's take each of these values. If p is equal to 5, now let's have a look at this one here. P is equal to 5. Now from here you can calculate. We had 2n equals 3r. I'll just hold that. I'll put that in deep freeze. Okay, that is something else. But knowing p, I can work out what r is because you got 8 minus r. Here, I can make r the subject of the formula. 8 minus r is equal to 2p divided by 5. Right? So now I know 3 values of p. P is equal to 5 or 10 or 15. But let's just make r the subject here. Therefore, r, right, is equal to 8 minus 2p over 5. Because if you bring r to this side, then take 2p over 5 to the other side, then you have, and now you know 3 values for p. So let's take them one at a time. When p is equal to 5, 5 times 2 is 10. 10 divided by 5 is 2. 8 minus 2 is 6. And like that, when you put p equals to 10, 10 times 2 is 20. 5 goes in 24 times. 8 minus 4 is 4. And the last one you will see is 2. And like that, now you got p and r. Now, but then now n becomes immediate because you got p is 5, 6. The 3 numbers add up to 20. So you'll have 5 plus 6 is 11. And the other one has to be 9. 10 plus 4 is 14. And the other one will have to be 6. And 15 plus 2 is 17. So n will have to be 3. So these are, so the question is, list in the form of P, N, and R all the different ways you can spend all his money. So you can put this in brackets, P, N, and R. Okay, pens, notebooks, and rubbers. Right? We have P is 5, and 6, and 9. That's 1. Then when P is 10, you have R is 4, and N is 6. And finally, when P is 15, R is, oh, I'm sorry, N, it should be the other way around. Sorry, N is 9, 6, or 3. So let's make this P, R, and N. But the questions asked you for to work P, N, and R. So we have to just interchange these. Sorry about that. So the last one is P, and N is 3, and R is 2. Okay, so there are 3 possible solutions for P, N, and R. And every one of these, if you check it out, you will see that when he spends all the money, he will be spending exactly 100 rands. As said, if you'll have to buy 15 pens, 3 notebooks, and 2 rubbers, and you would have spent exactly 100 rands altogether. Which is, see, it's very, this is a very useful way of solving these problems. Many of these problems are like this. You'll have to use a certain amount of logic to solve these problems. I want you to go and study this thing very carefully so that you can solve all problems of this type. Okay, we're going to go on with other problems like this. This kind of problem comes in the area called number theory, which is a huge field in mathematics, a very interesting field, which a lot of people around the world are number theorists. So it means that they work with numbers which are integers. They don't work with numbers which are other numbers, real numbers, and so on and so forth. They work with numbers which are integers. So these problems are integer problems. Okay. There's somebody whose mic is open. Can you please shut your mics off? Can you please take your mic off? Otherwise, I'm going to ask Khotso to remove you from the room if you don't take your mics off. Please do that. And also, please don't write on my screen. Sometimes you get people who suddenly, draw all kinds of things on my screen, and I can't take it off. It really messes me up. Now, for how many positive integers k does the equation kx minus 12 equals 3k have an integer solution for x? So let's just try to understand what this question says. So you have an equation, kx minus 12 equals 3k, right? And you want an integer solution for x. So let's solve for x, because they're asking you to solve for x. So you have kx, bring it to one side. Or better still, I can put k into x minus 3. The k is on both sides. Let's take minus 3k on the left-hand side. Then you get kx minus 3k, and I've taken the k out. And if you put 12 on the right-hand side, and here you have a product of 2 integers, because x is an integer and k is an integer. You got the product of 2 integers equal to 12. But positive. That's very nice. So we don't have the negative values for k. So k is a positive integer. All right. So you're looking for a positive integer such that when you multiply k by something, you get 12. So this will also have to be a positive integer, but we're not interested in that. We're interested in k. What are the values for k? So k is a positive integer, which is a factor of 12. K is a factor of 12 because you are multiplying two integers to get 12, and it's positive. Now that's easy. You can know exactly what k is. K is 1, 2, 3, 4, not 5. 5 is not a factor of 12. 6, and the last one is 12. Right? I normally write down 1 times 12, 2 times 6. I'll put them like this: 2 times 6, 3 times 4, and stop there. All right, then that way I've got all my factors. So the answer is, for how many? The answer is 6. So this is an easy problem. See, there are 6 values of k, and the question is for how many integers, positive integers, and the answer is 6. Okay, so that takes care of problem number 2. It gets more and more interesting as we go along. These kinds of problems are very interesting. And number theory is very beautiful. I like number theory. So let's get on to the next one. And if you do enough problems, you'll be able to get a lot of techniques. So that is why I'm doing all these different types of problems here, so that when you see them you will you'll have an idea as to how to solve them. Now, find the value of k plus L if k and L are positive integers, and you got some equation involving this. Okay, so and they're not asking for k and L, they're asking for k plus L. But for whatever it's worth, you need to calculate k and L so that you can add k plus L. All right, now if you look at this equation, you got two unknowns with one equation. So as we saw before, the nice thing to do is to solve for one of them in terms of the other. This can be done because you got one equation with two unknowns. Let's bring all the k's to one side, for instance. And then you land with k plus kl. And bring the 54, the one which doesn't have a k, you need to bring it to the other side. So you bring all the k's to one side. This is how you solve equations. Bring all the x's to one side. So here you got k's. So I'm trying to solve for k. Then I get k into 1 plus l. Take it out as one factor. 54 minus l. And then, therefore, I can work out k in terms of 54 minus l over 1 plus l. Now, these are positive integers, so maybe you can try writing down different positive integers. Say l equals 1. You see l equals 1 doesn't work because you have 2 at the bottom. The 54 minus 1, which is 53. 53 over 2 is not an integer. So l equals 1 doesn't work. And then you can try different numbers, l equals 3 and so on. But this will take a long time. There are so many different ways, so many positive integers you have to substitute here, and then try to get a value for k to see whether it's an integer. It's an interesting problem. Now, there's a very nice way of solving this problem. What you have to do is to create a 1 plus L, create a 1 plus L at the top, so that, and then thereafter, I'm going to use this fact here that a plus b over c is the same as a over c plus b over c. Right? You can do this. If you solve this, you see c is a common denominator, and you'll get that. Now watch out. That doesn't mean that c over a plus b is equal to c over a plus c over b. No, yeah, you got some other stuff here with this common denominator. So be careful. As long as you got a single number at the bottom, then you can do things. Now I got 1 plus L at the bottom. Right, I want to create a 1 plus L at the top. So what I'm going to do is I'm going to put 1 plus L. I'm going to force 1 plus L here. All right, but now I must balance this thing out. But I got minus L here. So I have to put minus like that. Now I got minus L. I got minus 1, which is remaining, and I got 54 here. And what must I put to respect this equation? I got minus 1. I have to put 55 here. So 55 minus 1 is 54. And now these two are exactly the same. But I had to put a minus sign here because I got a minus L here. If I had a 2 here, 2L, then I have to put a 2 there. See? So now you've got this. Now I've got my 1 plus L, but there's a minus sign in front. But I can say that this over this is what I've got here. A over C. A plus B over C is A over C plus B over C. So this is minus 1 plus L over 1 plus L plus 55 over 1 plus L. Okay. Now, why is all this very nice? It's because the first one simplifies to just minus 1. So you get minus 1 plus 55 over 1 plus L. Now here, this is beautiful because I've got a number here. And this is an integer. It's a positive integer. Because it's k, you see. K is a positive integer. It is, we were told that k and L are positive. Now this is an integer, negative 1. So for this whole thing to be an integer, 55 over 1 plus L must be a positive integer. Is an integer. Let's first say, okay, and this is great. This is a positive integer. So for this whole thing to be positive, you'll have to have that 55 is greater than 1. Because this has to be greater than 1 for this thing to be positive. Right. You can't make it equal to 1 because then you get 0. So now you got this number here is a positive number and it's an integer, which means that 1 plus L is a factor of 55. I see how beautiful. If you want it to be an integer, this thing has to, for this to be an integer, this is supposed to be a factor. If it does not a factor, like 4 or something, 55 over 4 is not an integer. But 55 over 5 is certainly an integer. So, and the reason for that is this bottom part is a factor of it. So 1 plus L is a factor. So what are the factors? The factors of 55, you can write them down. It's 1, 5 is the next one. This is 5 times 11. 5, you can have 11 and 55. There are only 4 factors if you check it out. Right? If you remember, the number of factors of a given number is, this is a factorization into 2 prime powers. Both of them are 5 prime numbers. So it's 5 to the 1 times 11 to the 1, 2 times 2. That's the number of factors. You have to increase each of them by 1 and multiply them, which is 2 times 2, which is 4. So this has got 4 factors, and these are the 4 factors. Now, 1 plus L equals 1, you'll have to eliminate it because then L is 0. It's out, right? And even here too, you try this thing out. If 1 plus L is equal to 55, then you get 55 over 55, which is 1. If you go back to this equation, and minus 1 plus 1 is 0, you're not allowed to do that. So therefore, 1 plus L is either 5 or 11, because these two will give you K is 0 or L is 0, and it's quite clearly stated that they are positive. So you have to use all these facts here. So 1 plus L is 5. It means L is equal to 4 or 10 in this case. And when you calculate K, you'll see that K is 10 or 4. I'm not going to do it, right? You just substitute it somewhere. And the problem is to find K plus L. So K plus L in the first case is 4 plus 10, which is 14. And in the other case is 10 plus 4, which is still 14, right? So it means that K plus L has only got one value, because if K and L are these two, the sum is 14. And even these two, they're still 14. Although there are two possible values for L, you will get only one possible value for K plus L. So that's the answer to this problem. I want to show you another way, a very clever way of doing this thing. And here it's a more advanced solution. But since we're doing problem solving, I'll show you a neat way of solving this problem. Don't have to do it this rather long way. You see, K plus L plus KL is equal to 54. Now, I notice that K plus L into K plus 1 is equal to 54. Because these two, if I take out the L, I'll have L is a common factor. Now, I want to write this as a product of two integers. If I can write this as a product of two integers, then I can solve it. That's what we've seen before. When you got a product of two integers is equal to a known integer, then you can say, what are the possibilities? Now, how do you get the product of two integers? I've got K plus 1 here, so why don't I put first a K plus 1 here? And then K plus 1 becomes a factor, you see. So if I add 1 to both sides, then K plus 1 becomes a factor of the left-hand side. See, now you got K plus 1 plus L into K plus 1, 54 plus 1. The K plus 1 comes out as a common factor, and that is 1. K plus 1 goes into this one time. And here L, if you take it out as a common factor, then on the left-hand side, you got this. 54 plus 1 is 55. And there you have it. You got K plus 1 is a factor of 55. Or even 1 plus L is a factor of 50. You see, you come right up to this. It means very, very quickly. Right? So then after that, you proceed as we did there before. Because now you got a product of two numbers is equal to 55. So each one will have to be a factor. See? Each one will have to be a factor. And therefore, you can write down the factors and work it out. So this is a neat way of solving this problem. So there are two ways of solving the problem. Okay, let's now, maybe there are other ways, but I'm saying I've got exactly two ways, at least two ways. Now we get on to the next problem, which says the following. How many integer solutions are there for the equation x squared equals, well, minus 125y cubed is 2017. Now, let me just divide this thing up too, so I have enough space. So now, how do you solve a problem like this? You got a square here, again, integer, so that's nice. We are still working in number theory. Both x and y are integers. Could be positive or negative, because they don't say positive. Integer, it could be a negative number like -5 or whatever. So you got one equation with two unknowns, but unlike the previous one, you got a square and you got a cube here. which is very unpleasant. It's very unpleasant. But what is nice is that you got the square of an integer. Also, I think people are still walking in at their own free time here. It's already 17:45. Can you just leave them in the waiting room and don't admit them anymore? I think they have to learn a lesson that they have to be here at 5 o'clock. They must be here punctually at 5 o'clock. All right. I do understand in some cases they've got some extra work to do, but a lot of people who are coming in are just coming in their own time without any valid reason, I think. So, although even if they have a reason, they must make it a priority to be here in time, not to come at 45 minutes late, okay? So please close it. I don't want any further disturbances with people walking in and at all odd times. Okay. Now, I've got the square of an integer. Let's analyze the square of integer. You see, the square of an integer, if you take any integer, it can only, the square can only end in a few places. Look, I'll show you. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. If I square it, and look at the ending. In other words, the last digit of the square. 0 squared is 0, 1 times 1, 2 times 2 is 4, 3 times 3 is 9. Now 4 times 4 is 16, so it ends in 6. 5 times 5 is 25, ends in 5. 6 times 6 is 36, so it ends in 6. We already got that. 7 times 7 is 49, it ends in 9. We already got that. 8 times 8 is 64, it ends in 4. We already got that. And 9 times 9 is 81, it ends in 1. Now, all the other numbers, like 10, 11, 12, 13, and so on, even those, this ending will still be the same as the ending for 11 times 11 will end in 1, 12 times 12 ends in 4, because you only bothered about the last 2 digits to find out what these numbers end in. So if you take any square number, they can only end in those few numbers. So the square of an integer ends in 0, 1, 4, 9, 6, or 5. So there are only 6 possible endings for the square of an integer. All right, so now we'll try to exploit that because we know what this thing ends in. So let's look at x squared and make it the subject is 125 y cubed. If you're taking it to the other side, plus 2017. All right. So this is a square, so it ends in only these values, 0, 1, 4, 5, 6, or 9. Right. Now this 125 is an interesting number because 125 y cubed, let's see what this will end in. Okay, now when you take, let's try a couple of possibilities here. Let's take 125 y cubed and see what it ends in. Now y is an integer, so let's take certain values for y and then put 125 y cubed, or then y cubed, and then 125 y cubed. All right. So let's see what these things end in. Let's try different integers. I'm going to take positive integers to make life a little bit easy. So you got y, if y ends in 0, now here ends, we're looking at the ending. I want to know what the ending of this is, and then I will add that number, which is a fixed number. Then I can work out the ending of these two things. But we really need to work out the ending of this, and y is any integer. So y is 0, and 125 ends in 0. If y is 1, 1 cubed is 1. 125 times 1, this ends in 5. So it ends in 0 here, ends in 5. When you take 2, 2 cubed is 8. 125 times 8 is 1,000. And that ends in 0. If you take 3, 3 cubed is 3 times 3 is 27. And 125 times 27, oh, but you know what it's going to end with, because this is a multiple of 5, you see. So this is a multiple of 5. So the multiples of 5 end in 0 or 5. In fact, I don't have to do all these things. At this place here, I can say 125 y cubed is a multiple of 5. And so ends in 0 or 5. Multiples of 5 can only end in 0 or 5, 5, 10, 15, 20. We love the 5 times table when we were young. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. You don't have to remember all those horrible numbers, 5s. So now I can see immediately what the right-hand side ends in. So you got 125y cubed plus 2017 ends in, this ends in 0. If it ends in 0, then this thing ends in 0 plus 7. Or if this ends in 5, then you got something which ends in 5 and you're adding that to this, or 2. All right, so this thing here ends in 7 or 2, and this thing here never ends in 7 or 2, you see? It can only end in those numbers. So it's impossible. This will always be a number which is never be equal to this, because its ending is different from the ending of this. So how can they be equal? Right? So the two can never be equal. Which means that there are no solutions. You ask how many integer solutions are there for this equation? The answer is 0. Right? How many? 0. There are no solutions. It's a very nice problem. It's not difficult, but you have to know these little facts here. Right? This is one of those things which you have to store in your brain. The squares of integers end in this, and then you have to use some logic. Here you say, well, this is a multiple of 5, and you know what the multiple of 5 ended. So what the idea is, you have to look at what the ending of this is. Otherwise, and that solves the problem. So that's the creative part of this. See, so if you don't know that technique, then you'll be battling around trying to find solutions for this. You spend the rest of your life and you'll never get any answers. Why? Because there are no solutions. But mathematics tells you very quickly how to prove that there are no solutions. That's a nice thing. Now the next problem is Piet writes down a 5-digit number. Okay, now we don't know what this 5-digit number is, so let's call it let Pete's, or Piet, I don't know how you say this, Pete's number be, it's a 5-digit number. I'm going to write down A, B, C, D, E. It's 5-digit. This is not a product. These are all digits. Well, I was supposed to separate my two parts here. So I have space. All right. So this is a 5-digit number. So these are all digits now. 3, 1, 9, 0, 1, 5, and so on. Now this is a 5-digit number, which means that A can't be 0. A will have to be at least 1 for it to be a 5-digit number. But these could be 0 or 1 or whatever, these numbers here. All right. Now let's see, what does it say? It deletes one of the digits to form a 4-digit number. So you've got A, B, C, D, E, and it deletes 1, right? If he knocks off A, if he deletes A, then you got B, C, D, E, E, B, C, D, E. If he deletes B, you have A, C, D, E. It says it forms a 4-digit number. If you delete C, you got A, B, D, E. And if you delete D, you've got A, B, C, E. And if you delete E, you got A, B, C, D. Right. Now, if the sum of the original number, in other words, this plus any one of these, right? If the sum of the original 5-digit number and the new 4-digit number, this is what we got here, this sum here is equal to 5, 2, 7, 1, 3. Find the original number. Oh, this looks like a very hard problem. Right. We don't know 5 unknowns. All right, but now this sum here is 52713. Now you'll notice this. This is interesting. This plus this, the ending is E plus E. It means that you're going to get an even number at the end because you got E plus E. And that's twice E. You're going to get an even number. Right? 2 plus 2, 1 plus 1, 3 plus 3 will always be an even number. But this is an odd number. So this is out because this one here will give you an even number, and this all this, all these will give you an even number. The only number which remains is that one, right? So therefore, we can conclude that E was eliminated, right? Because all the others would give you an even number. I hope you understand that. So E is eliminated. So you have this now. You have A, B, C, D, E. That's your 5-digit number. Plus A, B, C, D is equal to 5, 2, 7, 1, 3. We still you got 5 unknowns. We still got 5 unknowns. But the interesting thing is that this 4-digit number is appearing here in the front. This is a 4-digit number. So let's give a name to that because then we can eliminate 4 unknowns one time. See? So let's give a name to this. I'll call it N. Be A, B, C, D. Right. This is a 4-digit number. Right. So now you've got you got this 4-digit number with an E at the end. So it looks like this now. Don't let this fellow in. Thought so. All right. So you got, let's rewrite this thing. You got n, which is this 4-digit number, with the e plus n, right, is 52713. And this is not a product. The units digit is e, and that number is n. You can write this thing in terms of n and e. Like for instance, if I got a 4-digit number like 25613, and this is your n, this is really 25610 plus 3, right? Which means you now this is the multiplication, 25610. So this is 10 times 2561 plus 3. This is your units digit e, and this 4-digit number is 10 times that. So this number here is 10n plus e. Now I've only got 2 unknowns now. See, and now this is not a 5-digit number. Now we have an ordinary equation. The 10 times n, where n is a 4-digit number, and e is a single digit, plus n is equal to this. You got 2 n's here, so you got 11n plus e is equal to 52713. And remember, e is a digit, so e is one of these numbers. E is equal to 0 or 1 or 2 or 3 all the way up to 9. And so this number here is smaller than 11. All right. And when you see a thing like this now, I want you to just notice this, because it's very, very, very important in number theory, or in all these problems. I'm going to create a space here. You see, you got a large number, 52713, and it's written as 11n plus e, where e is smaller than 11. I want you to notice that. Right? Now, watch the following. Just take your mind out of this, and I want you to make the following observation. Suppose I divide, say, 43 by 8. The quotient is 5, and the remainder is 3. Now, what does this mean? It means that 43 minus 3, the remainder is 3. So if you remove 3 from that, right, you'll get 40, which is 8 times 5. I'm going to repeat that. When you take away the remainder from 43, you will have a multiple of 8. Right? So in other words, 43 is equal to 5 times 8 plus 3. Right? And 3, why 3? Because 3 is smaller than 8, you see. So it's really, you're dividing by 8, the quotient, the remainder will always be smaller than 8. You can't have a remainder. When you're dividing this, you can't have a remainder which is 8 or more. You know that. That's a rule. You were never conscious of it, presumably, but whatever you're left with must be smaller than 8. Now, here you have the situation. You have this thing here is smaller than 11. So really what's happening here is that you are dividing this 527 by 11, and this is the remainder. Right? Just like how you got here, this 43, if you divide it by 8, you get a quotient of 5 and a remainder of 3. So I've got a similar thing here. So I'm going to divide this 5271 by 11. So 11 goes into this. 11 4 is 44. Remainder 8. 11, 87. 11 times 7 is 77. Remainder 10. Then you got 101 here. 11 goes into 101 9 times. 99. Remainder 2. And 11 goes into 23 2 times. 11 times 2 is 22. And from 23, you got a remainder 1. Now, what does this mean? It means that 52713 is 11 times 4792 plus 1. I'm sorry, 92. 4792 plus 1. And there it is. You got this thing here is 11. When I divide it by 11, it's 11 times 4792. I just divided this number by 11 and I got the remainder 1. Right. So now you can see what n is. Therefore, n is 4792. And E is 1. So our original number, this part here was your n, Pete's number. And so your 4-digit number, there it is, you got your 4-digit number, n. Let me just do this. This is your A, B, C, D. And E is 1. So therefore, find the original number. The original number is A, B, C, D, E. We've got A, B, C, D is 4792. And E is the remainder. Beautiful problem. How you could actually solve this problem given this very scant information, right? By recognizing a couple of things here, namely that any number, you say 387 is 38 times 10 plus 7. Or otherwise 300 is equal to 300 plus 87. Or if you want 3872 is 3000 plus 872. So that's very useful because now you can say it's 3 times 10 cubed plus 872. See? So if you can just worry about the last few digits. It could be E or the last 2 digits, the last 3 digits. It's a useful thing to remember that you can write that number like that with the power of 10. Like here, you've got 10 itself. All right, I'm sure we're going to come across some other problems which will use this. So this is the answer to this problem. Okay, now we have to go on to the next problem. Okay, it says that a positive integer n has a property that when the last digit is transferred to the front of the number, the new number is 5 times the old. Okay, I want you to listen very carefully to this because your assignment problem is something like this, right? Your assignment problem is something like this. So just watch the solution to this problem. Again, it's very similar to what we did there before. A positive integer n has a property that when the last digit is transferred to the front of the number, then the new number is 5 times the old. The only problem here is that you don't know how many digits it's got. Before we said it's a 5-digit number. Now, we don't know how many digits it's got, God forbid. So it could have 1,000 digits for all we care. So how are we going to find n? If they're asking for the smallest value of n, right? Not n, but the smallest value. Okay, so what we have here is n equals, let's just put something, 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 something. And the last digits, let's call it x. I'm interested in that last digit. Right? Oh, why not? Why not give a name to this one here? Let's call this capital N. Right? This part here. No, that's not going to help. Or maybe it can. Then when you put this number at the end, it says that the last digit is put to the front. Now, when you do that, then the N comes here. Right? And this is the new number. This is equal to 5 times the old number. And so there's a problem here because you see 5 times, this is the old number. Try it like this. Now, the point is now, this number here, can you write it in terms of x and n? You got x right in the front here. So this is the new number. Okay, I hope you understand this. You've got x with n. This is the front number, the number in front of x is equal to 5 into n x. Now remember this is not a multiplication. Oh, I think we better be a little bit careful here. Otherwise, we can get thoroughly confused. Right? Or you might get confused. Let's just remember that these are all placeholders. Right? These are all placeholders. So what we have here is, what is the value of this? Like for instance, now if I had, say, x is 2, and I have 1, 5, 3, 1, like that, make it 4. And now I put it as 4, 2, 1, 5, 3. Right? Now I'm interested in this part here. Now what is this? This is really 4,000 or 40,000 plus 2153. Right? So it's 4 times a number of digits, number of zeros, but it all depends, the number of zeros here depends on the number of digits your n has got. See? Your original number has got. So we need to give a symbol to the number of digits in n. So let's just do that. So let the number of digits in n, the number that we got, be, we'll call it m, right? We don't know how many digits it's got. Okay, now, so what does this mean? Now, as we had here, if you take an example of, I'll take the same example, something 2, 1, 5, 6, 3, and then I make that 3, 2, 1, 5, 6. That thing goes to the front, and now you got 3, 2, 1, 5, 6. The new number is 5 times 2, 1, 5, 6, 3. Right? It's not, but because we are looking for the solution. So we're comparing these two. Right? Now, this number here is of interest because this is 3 times 10 to the power of 4. Three times 10 to the power of 4 is 30,000 plus 2156 is equal to 5. Now you got 21563. So this is 10 times 2156 plus 3. Okay, so I'm trying to isolate this number here, which is repeated in this, right? So bearing that in mind, this number here, 3 is your x now. So on the left-hand side, you got x, right, times 10 to the power of, now you got 4 here. Originally, we had 5 digits. This is 4. So we got m digits. Now we have to make this m minus 1. That represents the 4 there. And x is the number which was at the end, which you push to the front, plus this number that we are looking at in the front, right, is n, that one. That's your 2156. That is equal to 5 into 10 times n plus 3, plus x, right? 5. This number here is 10. You see, here it's only the last digit. So it's 10n plus x. Okay, it's rather complicated, but if you think about it a little bit, you'll see that eventually you'll end up with this equation. But remember, this n here is the original number is n with an x at the end. So we need to work out the smallest value of small n. Okay, so we have this equation here. Let's just bear in mind that n is actually equal to, the original number was 10n plus x. That's your number, which we had. That x was at the end. And the last digit was transferred to the front, and you got this equation here. Right, now, let's focus on this equation that we have. We have x to the power of, sorry, it's looking rather complicated, plus n. Yeah, I got 5 times 10n plus x. 5 times 10, I'm going to expand that. It's 50n plus 5x. Okay. All right. Now, oh, that's nice. You got 2 unknowns here. Right. You got 2 unknowns. And one unknown, you can make it nice. 50n minus n is 49n. Right. Bring it to this side. And the other side, you got x into 10 to the power of m minus 1 plus 5. Because I'm taking the 5x to that side, taking the x out. And now I have numbers here. And I got 49n. All right, so what does this mean? You got a product here. You got 49 times n equals x. Now x is the digit. It's a single digit. So obviously, this 49 is a factor See, all these are whole numbers. So 49 is a factor of this side because it's 49 times n. So 49 is a factor of x times this, but x is a single digit. So the only 49 can't be equal to x, but it's a factor of 10 to the power of m minus 1 plus 5. See? So you're looking for that. And now, see, everything is brought down to just a single m here now. So you want to know what is the smallest value of m for this to work. All right, now, so that involves a little bit of calculations. And just to sum up now, we had this rather complicated looking equation here. We wrote this complicated, there are only two unknowns here, x and n, although it looks quite nasty. And what I did was, I separated the n's and the x's, and I come to this thing here. And from there, suddenly I make a statement which doesn't involve n or x, which is beautiful. This is a multiple of 49. We are working with integers. This is a multiple of 49. Don't worry about n. And this is a multiple of 10 to the m minus 1 plus 5. So 49 is a factor of this side. Therefore, it's a factor of this side, but x is a single digit. So 49 will have to be a factor of this. Oh, but not quite. You see, x could be 7. If x is 7, yeah, so let's just worry about that. We can't make this conclusion yet, sorry. X could be 7, and I'm going to make x equal to 7. I want to make this n as small as possible. So right, let x be 7. Let's see what happens. Let x equal to 7. Then what you have is 7n, right? The 7's cancel, is equal to 10 to the power of m minus 1 plus 5. Right. So you got that this is a multiple of, so x is 7, so you have 7n is equal to this, x cancels. And now what are the different values now? So 7n, now this is a power of 10 plus 5. So it could be 15. Oh, this is a minus 5 here, sorry. The x is pushed to the other side, so it's minus 5. Sorry, I made a mistake there. The x was carried over to the other side, so it's minus 5 here. Let me. So if m is equal to 1, the 10 minus 5, 100 minus 5, 1,000 minus 5, or so you can try various things. Now, 7n, so this number here must be a multiple of 7. This is out. When you try to divide this by 7, it's not a multiple, not a multiple, not a multiple. But here, I think you have 4 nines. When you divide this by 7, you get 1, 4, 2, 8, 5. It goes exactly. Right. So this is the smallest number that you have on the side, right? So 7n is equal to, there could be some other ones there, but the smallest value is this. So therefore, you have that n is In this case, you have n is so 7n. So n must be 14285. In this case, and your small n will be equal to 10 times this, 14285, and times 10, and the x was 7 in this case. We chose x to be 7. Right. Now, if x is not 7, then n is larger. I'm not going to discuss this. This is the smallest. You're looking for the smallest value of n. If x is not 7, n will be larger. The small n will be greater than 142,857. You can check this thing out and try to argue it out, but this will be therefore this will be the smallest. And when that happens when x is 7. Okay, so that takes care of that. It's quite a hard problem, that. And the problem that I've given you is also similar to this, so it's quite a challenge. I hope you can succeed in solving that problem. Okay, so let's get on to the next problem. I don't know what I have for time. Doesn't look as if I have 1, 2, 3, 4. Oh, there are 4 problems left, and I've got 4 minutes. Okay, look, guys, I'm going to finish these 4 problems. Unfortunately, I'm going to go beyond the time. But if you need to leave, please leave, and you can go and look at the recording. Khotso, I must apologize. I'm going to go on for a little bit while. Okay, so the next question is, if you write the integers 2, 3, 4, 6, 8 in every possible order to form 5-digit numbers, how many of these numbers will be divisible by 11? So now this problem here is involving divisibility by 11. So if I take, for instance, I write this to form a 5-digit number. Say I take, for example, 864, 862, no, 468, 84632. Right. Okay. This is a 5-digit number. Now, is it divisible by 11? Is this one of the numbers? Well, the way to do this is you add the alternate numbers. Remember, divisibility by 11. You get 8 plus 6 plus 2. Add the alternate numbers. And the other sum is 4 plus 3. Subtract those two and see whether that number is divisible by 11. So you got 16 minus 7 is 9. So this doesn't work. This is not one of the numbers which will work. Right? Now, there are many, many combinations. Yeah, actually, there are 120 different ways in which you can write this. It's 5 factorial. Just think about that. We've already discussed this before. So there are 120 such numbers, but the question is, of those, how many of them are actually divisible by 11? Okay, so now how do you go around doing this? So what you do is you need to take these numbers here, 2, 3, 4, 6, 8, and you have to split it into two groups, right? You got 2 elements, and you got 3 on the other side, and we're going to subtract them, and you will see whether that answer is 0. You want it to be you want it to be equal, or otherwise a multiple of 11. All right. So or maybe 0 or 11 or 22. This difference must be either, it must be a multiple of 11. That's the rule for divisibility. Okay, so how do you do this? Now, the interesting thing here is that if you add up these numbers, so suppose you solve the problem. You got A and you got B. B has got, say there are two numbers here, and A, say, has got three numbers. All right? Now, we know that all these five numbers together will be the sum of these five numbers. That's 2 plus 3 plus 4. You get 23. Right? But also now we need to know that A minus B is either 0 or 11 or 22. So it must be a multiple of 11. Right? The difference between these two things. Okay, so A minus B is a multiple of 11. Also, it looks as if somebody thought the class starts at 6:30, and they came into the waiting room. All right, so now we don't know which of these is right, but remember A is a sum of three numbers, so it's a small number, and B is also a small number. Now, it can't be 0 because, I'll tell you why. Because A minus B equals 0 means that A is equal to B, which means that this number here is twice A, and this is an odd number, so it can't be. If A minus B is 0, then A is equal to B, then you get 2A, and 2A can't be 23. So you have to eliminate that. And likewise, you have to eliminate 22, because the difference between these two sums can hardly be 22. Look at it. You got all small numbers. How can the difference between these two be 22? That's impossible. So you have that A minus B is equal to 11. So now that's the question. Now you got these numbers 2, 3, 4, 6, 8, and you have to take them two at a time and see whether the difference is 11. Right? If you take two and 3, you got 5, and you take this with 18, the difference is not 11. So you have to try out all these things, and it turns out that you'll have 2, 4, and then you have 3, 6, 8. See, this is 6, and 9 plus 8 is 17, and 17 minus 6 is 11. So you can actually try, by trial and error, you'll be able to see what the B is, which is 2, 4, and what A is with 3, 6, 8. All right, so here we go. We need to know how many such numbers there are. So now the problem becomes a counting problem. Oh, I didn't separate my screen, so therefore we have a problem here. Sorry about this. Let's just take all these things out. So what we've got here is, I need to know the 5-digit numbers. So let me try to count these. How many such numbers are there? 5 digits. Now, the 2 and the 4 will have to go in here. You could have 2, 4 there. Or you could have had 4, 2. That's also possible. And so you could have had 4, 2. And then you got these other numbers, 3, 6, 8. They have to be slotted inside here. All right, so let's take this one here. If you put 3, 6, 8, it doesn't matter where they are because the difference will be 11. See, it doesn't really matter where they are. So you can have 3, 6, 8 or 3, 8, 6 or whatever. So this can be done in 6 ways. How do I get 6? I can put 3, 6, 8, 3, 8, 6. Or I could put 6, 3, 8, 6, 8, 3. Or I could put 8, 3, 6, 8, 6, 3. In other words, all the possible ways in which you can arrange 3, 6, 8, and you know it's 3 factorial, if you like. That's 6 ways. Here too, you got another 6 ways. And these will be different numbers because you've got 4 and 2. So those are the only possibilities. So the answer is 12. Because there are 12 such numbers. You can actually list all of them. And these alternate numbers will have to be 2 and 4 because that's the only time where you get the difference is 11. Okay, so that is the answer to the problem. So if I want to close it up properly, there are 6 such numbers. In this case, right? You get 3, 2, 6, 4, 8, and so on. Right. And also here there are 6 such numbers. So altogether the answer is 12. Okay. So that's an interesting problem. There you are tested on divisibility by 11. All right, so let's just clear the drawings and we go on to the next problem. We're almost there. There are only 2 problems actually. So, well, this wouldn't take too long. Some numbers when divided by 7, 6, 5, 4, 3, 2 in that order, leave remainders 6, 5, 4, 3, 2, and 1. Determine the smallest such number. Now, I'm sure many of you can do this by trial and error. Or maybe not. Yeah. So what happens is, when you divide by 7, let n be such a number. We want such a number. Then what do you have? You have n. When you divide it by 7, okay, remember earlier on we said, when you divide it by 7, you have a quotient and you have a remainder. This will be the remainder. So you can write the number as 7 times something plus a remainder. But the remainder here is when you divide by 7, the remainder is 6. Right. So what does this mean? N is equal to 7 cubed plus 6. So n plus 1 is 7 cubed plus 7, which is 7 into q plus 1. Right. Now, when you divide it by 6, 6 cubed, 6, the remainder is 5. So you have 6, maybe something else, 6 q prime plus 5. And again, you see that when you add 1 to this, it becomes 6. So n plus 1 is also, n plus 1 is a multiple of 6. So the point is, in all these cases, you see, you got 5, 4, 3, 2, 2, 1. In all these cases, n plus 1 is a multiple. See, n plus 1 is 7 times something. So it's a multiple of 7. N plus 1 is 6 times something. Whatever the something is, it doesn't really matter. But it's a multiple of 6. And it's also a multiple of 4. is also a multiple of 3 and 2, right? So n plus 1 is a multiple of all of these. The smallest, so in other words, n plus 1 is a common multiple. So it's one number which is a multiple of all these numbers, and such a number is called a common multiple. Seven, 6, 5, 4, 3. It's a common one number which is a multiple of the whole lot. And you're looking for the smallest, so it means that you're looking for the least. Now I can put the least common multiple, and that is LCM, guys. LCM stands for least common multiple. So n plus 1 is the least common multiple of 6, 7, 6, 5, 4, 3, 2. Right? And when you can do it anyhow you like, and you will see that you can calculate this thing by any method you have, and you will see that n plus 1 is actually equal to 420. That's the smallest number, which is a multiple of all of these. Say it's 77 goes into it, and so on. So therefore, n must be 419. So the answer is 419. So this is a problem. You might not recognize it, but it's actually a problem on LCMs. Right? A beautiful application of LCMs. All right, now finally we get to this last problem. The last problem is this. Okay, now this is quite a hard problem. Okay, we have 30 people still in the class. So let's hope you understand the solution to this. A mathematics competition consists of 30 multiple choice questions. It's a very practical problem, right? The 30 multiple choice questions. 4 marks are awarded for the correct answer, and there's a negative marking. If you put a wrong answer, you're given -1. So you're not allowed to guess, in other words. You get punished. And if you don't put an answer at all, then it's a blank. So you got 30 questions, and some of them you got the correct, then some of them are wrong, and some of them are blanks. But whatever the case may be, altogether you have 30 questions. Question is, what is the minimal number of participants needed to be sure that 2 of them will have the same score in the competition? Now, that's a rather hard question. See, you got scores. Right? After you mark all the papers, you get some score. You can get all right. In other words, you got 4 marks each. So the total marks will be 120. So you can get all right, in which case you can get 120 marks. Right. Now you got a number of people who are writing this test. And you want to know what is the smallest number so that 2 of them will have the same score. Now the problem is that you've got a number of people, you've got 6 people, for instance, they can all have different scores. Right. But it's possible where you have got a large number of people, say you've got 1,000 people writing it. Right? But there are only maybe about 100 people, 100 possible scores. Then if you've got 1,000 people writing it and you've got only 100 possible scores, then you can be guaranteed that at least 2 people will have the same score. The score must be repeated somewhere. So it's all about how many scores you've got and how many people there are. So what are the possible scores? Okay, so the highest possible score is 120, as you can see, because then you get all right, all 4 marks. That's the highest score. Let's call it S for score. I'm going to separate this thing again, which I forgot to do previously. So if you got S for score, then S, the highest score is 120, right? The highest score is 120. But you can have some guy guesses all the answers and he gets all wrong, unfortunately. Rare situation, but he can get 30 negative ones. So the lowest possible score is minus 30. Right, you can get S to be minus 30. So in other words, that the possibilities for S are minus 30, minus 29, all the way, including 0 and going up to 120, right? So there are there are 151 numbers, 151 possibilities for S. Because you got 1 to 120, and you got negative 1 to negative 30, so that gives you 30 plus. But you count the 0, so 151 possibilities for S. So, like for instance, now 151, and if you got these possibilities for S, so for 152, if there are 152 people writing, you must have is a possibility. In other words, if there are 152 people writing, there must be 2 scores which are the same, because you got 151 possible scores, and one, if there are 152 people writing, then at the worst possible case, you will have all different, but that last number, it has to be given to one particular person again, a new person. So you'll have 2. You'll have repeats. All right. So, but now there's a possibility. But the question is now, what is the minimal number? Right. 152 is possibility, but it could be that there are smaller numbers than 152, which will still ensure that you've got 2 people who will have the same score. So the idea now is to find out what are the possible scores. All right, the 4s, they add to the score. So suppose we want to know how many people there are who've got 4. Let A participants have 4 correct. No. For a given participant, let sorry, this is not what we are saying. We are looking at one particular paper, and we are seeing how many 4s there are. Right? A equals number of 4s. B equals the number of wrong answers. That's -1. And C is the number of zeros. right? So in one particular paper, so you got A fours, B minus ones, and C zeros. So you have that A plus B plus C must be 30 because there are 30 questions altogether, right? So I'm trying to put some mathematics into this. And to do this, you have to say, how many fours are there? We don't know. How many B's are there? How many negative ones are there? Right? So what is the actual score here? The score will be the A's contribute 4 times A. The B's contribute, you have to subtract. Now, B times minus 1. You have to subtract B because these are all wrong. And the C's contribute nothing. So you get 4A minus B is the actual score. So what I've got here is, you see in this table, I've got possible values for A, B, C, and 4A minus B, right? And I've actually calculated all these things, and I could have had A is 30. Now that means you got a 30 right. So you got no wrong and no zeros, and that's where you get the total score of 120. But if you got 29, if you got 29 A's, you can't have, the B can be only 1 or 0 because the sum of these two is 30, you see. You can have 29, 1, 0 or 29, 0, 1. Those are the only two possibilities to get A plus B plus C to equal to 30. So in these two cases, the scores are 115, 116. That's easy to work out because this is 29 times 4 is 116 and 1 wrong, so this is 115. Here you got 29 fours and 1 blank, right? So you got 116 here, 29 fours. So like that now, if I come down from A equal to 30, 29, 28, in 28, you can only have 28 plus 2, 28 plus 1. No, yeah, these two could be 2, 0, 1 plus 1, 0 plus 2 to add up to 30. So there are 3 possibilities here. And for 27, again, you got 3, 1 plus 2, or 2 plus 1, 1 plus 2, or 0 plus 3. Right? You get these. But now when you go further down, you will see all these numbers occurring. See, starting from 108, you go backwards, 108, 108, 107, 106, 105, 104, 103, 102, 101. All these numbers are possible, right? Because we are saying so many right and so many wrong. Right? But here, there are some missing. Like 108, 109 is missing. So 109 cannot be attained. Can you see? It's not there. And then 110 is yes, 111 is yes, 112 is yes, but 113 is missing. So 113 is a score which cannot be attained. Right? 114 is also missing. 114. 115 is okay. But then 116 is okay, but 117, 118, and 119 are all missing. See, they're all missing. But from this onwards down, everything is attainable. Now that's not easy to prove. I've actually proved it, but we don't have time for that. So every one of these less than 108 can be obtained. You can choose A and B so that it works. Okay, I don't have time for that. Maybe the next time when we come, I'll try to show you that. But for the time being, there are 6 numbers from this 151 altogether, which cannot be. I said 151 possibilities for us, but 6 of them are impossible, right? Which means that there are only 145 different scores. So this 152 can be reduced. See, because 6 of these are not attainable. So it's 145. And to ensure that 2 of them will have the same score, you have to have more than, and that's the least number, will be 146. Because as soon as you hit 146, right, and anything more than that, you're assured of 2 people, at least 2 people will have the same scores. So the smallest n number is 146. In other words, if there are 146 participants, then you can be assured that 2 of the people will have the same score. These scores cannot be obtained. And as I said, it's quite a difficult problem, but if you decide you're going to start like this, work out the scores and start from the top, because some of the scores at the top are not attainable, but the scores at the bottom are. So that's the trick, to start from the top, and you will see which are not. Then from some point onwards, you see everything is attainable. You can get those scores. All right. So thank you for that. That is the last question that we have. And I've also got this assignment. I've written down the assignment here for your. So here you see no calculator, no paper. Find the digits that when you multiply this by 4, you get the digits are reversed. A, B, C, D, E goes backwards. 4 times this gives you the back number. There's only one number which has this property. Interesting number. So try to calculate just by logic here, but just pure logic. You can work out what these numbers are one by one. For instance, you know this is a multiple of 4, so therefore it's an even number. So A could only be even, right? And so this is a 5-digit number, right? But yeah. So when you multiply this by 4, this 5-digit number, you're still going to land up with a 5-digit number. So you have to ask yourself, what are the possible values for A? See? And then you'll see that A has got only one possibility. Put the value of A in, and then now you got 1 down, 4 to go, and keep using your logic to eventually get to the final answer. All right. So have fun. I'm now going to stop, and if there are any questions, we can address them. You see, I've got this problem are not easy, so that's why it takes a long time. I can rush through it, but I don't want to do it in such a way that you don't understand. Okay, guys, we have come to the end of this. Are there any questions? You can show by hand by raising your